Hello. Today we're going to be going over Objective 15, which is special factoring. We're going to cover two sections, the difference of two perfect squares and factoring the sum or difference of cubes. So first, we're going to talk about the difference of two perfect squares. So when you have the difference of two perfect squares, it's a squared minus b squared. So that is the difference of two perfect squares. So your formula for this is a plus b times a minus b. So this is a formula you'll want to remember of two perfect squares. So let's take a look at an example. If you have a to the fourth minus 81, well, do you have two perfect squares? Well, let's take a look. So a to the fourth is a squared squared, and 81 is 9 squared. So we do. So let's take a look at this. So we know then the difference of two perfect squares is a plus b times a minus b. So we're going to have, that's going to equal a squared plus 9, and then a squared minus 9. Well, let's take a look at one additional thing here. Here we have a squared and 9. Is that the difference of two perfect squares? Well, it is. So if we were going to factor that even more, then what we would have is a squared plus 9 times, so here we have a squared, that's a times a, so that's a perfect square, and 9 is 3 times 3, so that's a perfect square. So then we have a plus 3 times a minus 3. And then that's our answer that we have for the difference of two perfect squares. Now, let's take a look at the second topic here, factoring the sum or differences of cubes. So we have two formulas here that we want to remember. It's a cubed plus b cubed. So that always equals a plus b times a squared minus ab plus b squared. And we have a cubed minus b cubed, and that equals a minus b times a squared plus ab plus b squared. So those are your two formulas that you'll want to remember. So let's take a look at an example here. So we have 8a cubed plus b cubed. So do we have two perfect cubes here? Well, 8 is 2 times 2 times 2. That equals 8. We have a cubed, so that's a times a times a. And we have b cubed, that's b times b times b. So we do. So this, in this example, we have the sum. We have 8a cubed plus b cubed. So we want to use this formula here. So if we did that, then we have a, which is 2a plus b. So remember, this is the 2 times 2 times 2. So we have to have 2a. And then we have 2a squared minus 2ab plus b squared. And this part here, the 2a squared, we want to take that even further. So we have 4a squared minus 2ab plus b squared. So that's what we have there for that answer. Well, let's take a look at another example. 27 minus y cubed. Well, is 27 a cube? So if we take 3 times 3, that's 9, times 3 is 27. So yes, that's 3 cubed. And then we have y cubed, which is y times y times y. So we have 3 cubed minus y cubed. So that helps us sometimes if we write it in this order for us to see. So we're going to want to now use the a cubed minus b cubed, because here we have a difference. And so that tells us which formula we want to use, which is this one, the second one. So we know the formula is a minus b times a squared plus ab plus b squared. So let's substitute in our a value, which is 3 minus y times 3 squared plus 3y plus y squared. And we can take that one step further to be 3 minus y times 9 plus 3y plus y squared. And that is the difference of cubes. And so that's how you utilize these formulas. Hope you enjoyed the video. Thank you.